Okay, yeah, definitely the last video. I'm getting tired now. Getting tired. So this is an excellent question. Excellent, because there's very little maths to do in it actually, in terms of numbers, but it's all about understanding what's going on. Okay, so let's have a look. So we've got a quadratic, and it's defined on a set of real numbers. Okay. Diagram 1 shows we've got y is equal to fx with its turning point. Okay, and there's the roots. Diagram 2, we've got h of x with its turning point up here, and it's not shown as the roots, it's shown as this bit. Okay. Given that h of x is f, okay, right down a and b. So what it's saying is, this graph has been moved to generate this graph. So how have I moved this to get to here? Okay, well, how did I get from 2 to 7? How did I do that? Well, I've added on 5. Now we know when we're inside the bracket, it's the opposite. So that means it must be a take away 5. So that's going to be h of x has to be f x take away 5, because we do the opposite. And how have I got from 3 to 6? Well, I've added on 3. So that means we'll have to just do plus 3. The up and downs are quite simple, but it's the next to the x, we do the opposite. So that's all that's happened. This has been moved over 5 and moved up 3. And that's how we'd represent that, isn't it? I'll just write, plus 5. So that's how it appears in the graph. That's the opposite sign. Okay, so right away, that's very good. So a is -5, b is 3. Okay, good. Next, it is known that 3, 1, f of x, the x is 4, determine the value of a at 6. Okay, what does this mean? If I integrate between 3 and 1 for this function, the area is 4. So what that's saying is this area in here, okay, that area is 4. Now, they've tried to help us out here by drawing a straight line over there, which means that this bit in here is also 4, because it's the same. They're trying to be nice and show you, get 2 is our distance here, 2 is our distance there, yeah? So we're trying to be nice and show, well, if that's 4, then that's 4. So if we're trying to determine the value of h of x between 8 and 6, which is these two bits here, I already know part of it, I just don't know this bit in here, this kind of rectangle. So how to get rid of a rectangle? Well, it's the length times the breadth times height, whatever you want to call it. So that's 2. What's this height here? Well, we know we've moved up 3, haven't we? So from here to here, that's 3, because this line along there, that's that line there. Yeah. If I'll just draw in, there's the kind of box there. Do you know what I mean? So 3 times 2 is 6. 6 plus 4 is 10. So that means it's going to count as 10 units squared. I love that question. It's really making you think about your graphs, and it's making you think about, well, what is, integration? That's a tough question. So realizing there was a chorus, that the 4 was the same, all you had to do then was add on this rectangle. Okay, good. And the next one, we're getting differentiation now as well. So given that f dash 1 equals 6, show me h dash a. Okay, what does that mean then? So f dash is the slope. Okay, so at x is 1. I'll do this in another colour. What have I got left? Try a different colour. A goofy pink maybe. So the differential at 1 equals 6. So that means that when x is 1, the gradient there, so the gradient of tangent, is equal to 6. That looks right, doesn't it? It's a steep line. And it's saying, well, what's the value of h, the gradient of h, when x is 8? Okay, well, x is 8 is over here. Right. So what's that gradient? Well, how would I know that? Okay, well, if that one there is 6, that means that the gradient here, the differential here, would also be 6. The parabola is symmetrical about the turning point. So if this is 6, this is also 6. It's just negative, because it's going down the way, isn't it? It's a negative line. Yeah? So again, a great question, making you think, what does it mean? Dy by dx, f dash, what does that mean? It's the rate of change, it's the slope of the line. Yeah? So the slope of the line at 1 is 6. So what's the slope of the line at 8? Well, it's the same as that one, it's just negative. So for that one, you would say it's equal to -6. Fantastic, I'll just double check now, yeah. So an excellent question, because you're tying in all these different topics, and look at that, nice wee couple of marks you pick up for not a lot of maths, just more the understanding of what you're doing. Yeah, so I hope that was helpful. I did see that question, I think that was an excellent question. So yeah, that concludes our voyage and integration. So just a quick recap. The easy questions are simply just integrate. You know, add 1 to the power, divide. Make sure you do your setup first. So break it up if it's a fraction, multiply the bracket out if you've got one, change the sign when you cross the line. Okay. It gets harder when you're working out an area. This is what we use to work out the area, but there's no point. So there's no limits. So we have to write our plus c, but when there are limits, we then substitute those limits in, and this is where it can get quite messy. Okay, so really take your time. You know, I think I did take my time and make it nice and neat. Let me know if there's any mistakes. I think I checked it was fine. But it's very easy just to miss a little negative or multiply something the wrong way. Okay, so take your time. But that's what we're doing. We integrate between 2 points, and we substitute those in and get the area. Above the x-axis is positive. Below the x-axis, we get a negative area. So this might come out as, say, 3. The same on the bottom would be -3. Add them together would give you 6. Don't add them together and get an area of 0. That makes no sense. When you're doing the area between two curves, a line and a curve, you have to do the upper, take away the lower, first of all, and then you would integrate. Okay, don't do upper, take away lower, and forget to integrate. Make sure you do the integration as well. Okay. If you're doing these two combined, like I said before, you do it separately to get the area from this and the area from this, then add them together. So it's 2 calculations if you've got your functions crossing the x-axis. Okay, and that was all of them. And then it was just in context. Remember, your roots are, that's your synthetic division, your factorizing. Those would be the limits. They might make you work them out. And if you see something like rate of change or whatever, that's a dy by dx, and to get the y, you would integrate, and then sub your point back in to get c. So when you see something like rate of change, it maybe means you're going to be working back to the way doing integration. And then this one was just a nice one with the graphs, and it's just making you think a little bit about, well, what is integration and what is differentiation. Differentiation is when we get the slope of a point. Integration is the area between the x-axis and that line, or between a curve and a line if we select that. Okay, I'm knackered, so I'm gonna enjoy the rest of my night. I hope that was helpful, guys, and yeah, best of luck with your integration topic. Good stuff. Thanks.